whiteboard. Okay, so the last thing we discussing was the vector value function. And the vector value function is the vector, but this vector, the function, so the component of the vector is a function, 3 function, or 2 function, depending if it's 2D or 3D. Okay, so one fantastic application for the vector value function is the representation, the vectorial representation for the any curve. I bring three examples in 2 dimensions and 3 examples in 3 dimensions. And let's see after in GeoGebra. Look, example 1. Elementary. Always example 1 is kindergarten example. Suppose x squared plus y squared equal 4. It's obvious it's circle, no? It's obvious it's circle centered in the origin 0,0 and the radius 2. However, what is my goal? My goal is represent like a parametric equation similar to the calculus 2, and also the new thing in calculus 3 is vectorial, vector value function of this curve, because this is a curve, no? Entonces, good morning. Okay, good morning. Are you late, Restrepo? Divided by 4. Divided by 4. Why? Because I want to express in a standard. Then you have x over 2 squared. Ahí no is y over 2 squared equal 1. So I take advantage of this trigonometric identity that everyone knows very well, que es cosine square t plus sine square t equal 1, no? Entonces, si you define x over 2 like a cosine, you define y over 2 like a sine, when you square both is equal 1, no? Therefore, x alone is 2 times cosine t. Y alone is 2 sine t. This is a parametric equation. Wait. Relax. Always, when you define parametric equation, you define the domain of t. In this case, t varied from 0 to pi. T varied from 0 to pi. Okay, it's important. Without this information, it's incomplete the answer. Now the vectorial vector value function is open the angular bracket to cosine t, comma, 2 sine t. End the story. I promise that after that, when I finish the 2 dimension, we see in GeoGebra. But no, because I need to switch into GeoGebra and we waste the time in this operation. Any questions so far? Any question? This is super clear, right? So the new thing in calculus 3 is vector value function. Vector value function open the door to apply calculus. And what is the reason that you need to apply calculus? Because I want to study in detail the most important characteristic of the curve in 3D. Okay, example 2. You have no question? Yes or no? Clear, right? Guy, don't hesitate to ask me any question. Good, very good. Okay, suppose this equation. And remember, we are working in 2D. Okay, not 3D. Therefore, this represent. In 3D, maybe this represent a surface. But in 2D, no. In 2D, it's a curve. Okay, now to organize this a little bit, for example, I organize the x bar. So x squared minus 2x plus one number that completes the square, you know that idea, plus 2 y is 2, I factor out 2 y squared plus 4y plus another box. This is the organization. In the right hand side, I put -1, because this one gonna move to the other side, and 2 boxes. The number inside the first box is so big as 1. We come from 1, 2 divided by 2 squared. The formula is b over 2 squared. In our specific trinomial, in the x, b is 2. Or negative 2, but I don't care the sign. Now, in the second is 4 divided by 2, que is 2 squared 4. It's a coincidence, it's 4. So the number is 1. This one is this one. Actually, here no 4, it's 8 because 4 times 2 is 8, no? Okay, keep the equilibrium of the equation. Now factorization. In the factorization, we have x minus 1 squared plus 2 times y plus 2 squared equal 8. No new. This is called algebra. Now, this look like equation of the elixir. Entonces, any equation of the elixir you express in standard form. Divided by a, divided by a, divided by a. Entonces, we have x minus 1 squared over 8 plus y plus 2 squared over 4 equal 1. Entonces es obvio que the big number is a, therefore a is square root 8, que es 2 radical 2, and b es 2, que es 4, square root 4. Es el x, a and b. Dice el x es la que es horizontal, el x is supposed to be something like that, no? Because the major axis corresponding with the x part, no? And the center of this ellipse is located at the point 1, negative 2. Okay? But where's my goal? This is called algebra, no? Or precalculus, I don't know. It's expressed like a parametric and also expressed like a vector function, vector value function. Entonces es x minus 1 over square root a is 2 radical 2 square plus y plus 2 square root 4 is 2 square equal 1. So you define this guy like a cosine and this is sine. It doesn't matter what is cosine, what is sine. Okay, the only difference, if you define in different way, is maybe the orientation of the parametric. Orientation means the direction que travel. Pero bueno, no, okay. Remember, the parametric is not unique. There are many ways to express a parametric, no? And generate the same curve. Okay, entonces basically my cosine is this. Cosine t. And my sine t is this. Yeah, you know que cosine square plus sine square is 1. Entonces I write here in this corner x minus 1 over radical 2 radical 2, sorry, is equal to cosine t. Y plus 2 over 2 is equal to sine t. So for x or for y, we have x minus 1 is equal to radical 2 cosine t. Therefore, x alone is 2 radical 2 plus cosine t, sorry, plus 1. Super. And y, similar. Y plus 2 is equal to sine t. Therefore, y alone is 2 sine t minus 2. Entonces, this and this together is the collection of the parametric equation and your specification, the interval in this case is elixir. Entonces, elixir represents the closed curve and the parameter is from 0 to pi. Suppose que you don't know clear, you don't know the interval. Entonces, you put in your algebra and say your algebra, see when you generate that, don't cover the entire elixir like that. Let's say you extend it maybe 4 pi or 3 pi. Well, no, in this case 2 pi. The reason que es 2 pi is because the period, que es a repetition, is remember the period is 2 pi over omega, no? Omega is 1 in this case. Because the coefficients, si the coefficient es no 1, es 2, entonces the period is different. Pero no, entonces omega es 2, entonces period es 2 pi over 1, que es 2 pi. That is the reason que the periodic repetition cyclical is 2 pi. Okay. The vector value function associated with this is expressed like a vector 2 radical 2 cosine t plus 1, which term is omega. Omega is the coefficient from omega t. Omega t, cosine omega. Omega is 1 in this example. Okay. Comma, 2 sine t minus 2. End the story. I promise in a few seconds, no second, minute, I put this in GeoGebra and you can see the representation like a vector value function. Any question? No? Yes? Clear? Confusing? One more example. The last one in 2D. Example 3. Suppose this equation, x minus 2 squared divided by 4. Now minus y minus 3 squared over 16. Equal 1. Well, this is the hyperbola. How do you know? Because it's minus. When it's plus, it's ellipse. When it's minus, hyperbola. Entonces we can know using the famous trigonometry identity que you know before, que is cosine square t plus sine square t equal 1. No, we cannot use this because it's minus here, it's minus. Entonces we're using another trigonometry or not necessary trigonometry. So remember the parametrization is not unique. So I review quickly in the collection of the trigonometry identity. I discovered this. Secant square t minus tangent square t equal 1. Okay, entonces you, for example, you put a 4 here inside, the parenthesis x minus 2 divided by 2 square, minus y minus 3 over 4 square equal 1. And you declare que this is secant t, no? And this is tangent. It matching perfectly with our trigonometry identity. Es Pythagoras also, es another. Entonces I define que x minus 2 over 2 is equal to secant t, and y minus 3 over 4 is equal to tangent 3. Tangent t is the argument of the trigonometry. Therefore, the parametric equation is is x type copy directly 2 times secant t plus 2, and y is equal 4 times tangent t plus 3. Entonces, what is the interval? Well, the interval is, is in this case is from t que vary from negative pi over 2 and positive pi over 2. How do you know? Well, using your imagination, guys. You need to remember something. Okay, for example, let me recall quickly trigonometric. Cosine look like that. This is cosine. It's maximum in 0. And secant is here. It's similar to this idea. Look. This is secant. This is secant. This guy, secant. Entonces this is totally asymptotical here. This is 0, this is pi over 2, this is negative pi over 2. This is secant. And tangent is like that. Look at that. The graph green is tangent. Entonces, using my common sense and my imagination, I don't know, my knowledge about trigonometry, I realize que the domain for t is from negative pi to positive pi. You can assume another, yeah, well, no. Now, the vectorial is r of t is equal to secant t plus 2, comma 4 times tangent t plus 3. It's a vectorial representation. And we can see this in GeoGebra. We can use another function. Yes, we can use another function. I don't know if you see before the hyperbolic trigonometric function que es cosh t minus sin t equal 1. This is another. Do you see before a hyperbolic trigonometric function or no? No? Yes or no? No. Okay, forget about that. It's another kind. If you want to know, let me know. I sent to you one collection for the explanation for the trigonometry. Okay, let's move on to the GeoGebra to see our result before start 3 dimension. Let me try. Bang. Okay, share. Bang. Do you see your GeoGebra now? Good, very good. Okay, look at the beginning. Example 1 we discussed today was 2 sine and 2 cosine. Okay, this is no parametric. However, the parametric is, look, the new idea I want to emphasize. I explained the last class, but I want to re-explain again. To define parametric in GeoGebra and Desmos is a little bit different. I suppose in Desmos is easy, but okay, we are working with it. GeoGebra. You define a curve. You define the function g, the function f, que es 2 sine and 2 cosine. Es x component function, y component function, comma, the parameter que es t or any letter, not necessarily t. You put u, you put b, you put lambda, whatever you want, and the interval gets from 0 to pi. Bang, it's a circle. This fantastic. Okay, now this was example 1. Example 2, we have 2 functions. Bang, this is cosine something plus 1, and this is sine something minus 2. Now when you are doing the curve, bang, it's a ellipse. And by the way, the center of this ellipse is located at the point 1, -2. We discovered that. It's not new. Okay, but this is the parametric representation, que es the vectorial in GeoGebra. Finally, this is the secant. Bang. Look at the secant. Look at the tangent. Wow. Start cold. Why start cold? Now the parametrization is this. Bam. It's a hyperbola. Do you see? This is funny because the hyperbola included when you are doing that way. I don't know why. I suppose it's because we travel in one direction, you return, and you travel in another direction. So included the asymptote. Wow, it's fantastic. This. Any question, guys? Do you understand this or no? No? Confusing? By the way, I will send to you the GeoGebra script. Let me know if this is useful or not for you. It's useful. Who changed the background? I say I don't like that. How many times I need to say that? Okay, let me check in the attendance. Annette Cruz, Carlos Duque, David Restrepo, Jocelyn Hernández, Brandon Thomas, Omar Borja. Yeah, and the rest is coming early. Okay. I say this is the last time. Don't change the background. I don't like this. Okay. So I need to share. Switching to Wabor. Okay, in 3D it's a little bit more complicated. It's obvious, no? When you increasing the dimension of something, our problem is more complicated. So for example, suppose we have a circle in 3D. Suppose we have a circle in 3D. Circle in 3D. This is the theoretical part. After I promise I see 3 examples. This is the 3D, X, Y, Z. And we have a circle in 3D, like that. Suppose our circle is totally flat, like that. So we know the center. Always we need to go to you find the center. Entonces this is the position vector. I call R null. R null is the vector X null, Y null, Z null. And you generate the parametric equation similar to this, because we have a plane here. Okay, and the parametric equation look like that. Just like any point on the curve. This is the position vector, but in any point on the curve, is equal R of t is equal R null plus something plus rho. Rho is the radio. Is the radio. Normally it's called this Greek letter rho. Rho cosine t, comma, this is like a vector, comma, rho sine t, comma 0. Well, in this case, comma 0, because it's perpendicular to the z-axis. Entonces, the component, for example, you separate the parametric equation, no? Is x equal x null, que is the first component of the R null, plus rho cosine. Y is equal y null plus rho sine, and C is only C0. We have nothing here, and we have nothing here because this circle is flat. Entonces, when it's flat, this unit vector here is K, and you take, so one fantastic way, for example, to represent this n vector value function is R to any time is equal R null plus rho. So you put the unit vector like that, 1, 0, 0, is I, by the way, this is unit vector I, cosine theta, plus rho, because it's a circle, it's the same distance, es the distance in I direction, que es this, y en J direction, que es this. Bueno, I is this direction, J is this direction. So remember the unit vector, I, this is trihedral, 3 unit vector, 3 orthonormal vector, no? Okay. The K do not participate in the game, but I and J, yes. So the vector is 0, 1, 0, que es J, sine. Okay? This is the easy case in which the circle is flat, or it's a circle. So it's more complicated, for example, it's ellipse, and not flat, it's oblique. The equation is similar, but a little bit different. Let me show you. Suppose x, y, z, and we have ellipse like that. In one arbitrary plane, cannot necessarily parallel to the xy plane, like that. This is similar. We have the center, maybe you find, is R null vector. Entonces the formula is similar to this, except, so the formula is R to any time vectorial is equal R null plus something, but in this case, I suppose you have, because it's ellipse, no? You have two distance. You have this distance, and you need to find one extra point on the circle, and you find this distance, and this I call rho 1. and another distance perpendicular is rho 2. I want to explain how you find that. So it's rho 1 multiplication by I prime. Why is not equal to the traditional I? The reason is because the unit vector K here is no parallel to the z-axis. So I want to call K prime. Therefore, we have two vectors here. Suppose this is I prime, not the traditional I, and this is J in that direction, J prime. So this is the question is similar, except that you have no IJ, so you have I prime, cosine t, and rho 2, because I complicate again, okay, we have different distance, because it's elixir, no? Sine. Sorry, J prime, sine t. So for example, you have, number one, you have center. The center is given or you found. Que es x null, y null, z null. Number two, you find rho 1. Rho 1 is that distance. There are many ways to do. You travel onto the elixir. Entonces I want to explain another thing in a few seconds, que es el curvature. And the curvature is maximum. Entonces you determine rho 1 and rho 2. Why not? Rho 1, rho 2. Because this distance is perpendicular, guys. So, suppose. Big zoom. This is my elixir. It's the center. This is rho 1. And this is rho 2. And they are perpendicular. Entonces the vector, unit vector in that direction, I call I prime. And the vector in that direction I call J prime. Entonces you find rho 1, rho 2. Entonces it's relatively easy to determine the vector I prime. And the vector J maybe is a little bit complicated, but okay, no problem. The vector J prime you find using the cross product. So it's K prime cross product I prime. Because the vector K prime is a normal vector, the uninormal vector of this plane. Okay, and this is the formula. More general, more complicated, but don't worry, I try to do an easy way. Okay, let's move on to the example in 3D. Okay, maybe it's something is confusing or no. No? I bring example, easy example, no big deal. Okay, because you want to discuss and what is the difference between this elixir and the preview. The preview is no elixir, the preview was circle. And the radio 1 and radio 2 is the same. And now it's elixir. I try to generalize a little bit more. Okay? Okay. Okay, guys. So let's no more blah blah blah. Let's go to the example. Example 4, 5, and 6. Example 4. Example 4. Now in 3D. Suppose we have x squared plus y squared equal 9. And suppose we have x minus y plus c equal 4. Remember, we are working in 3D. For example, this equation, what represent in 3D? What surface, what figure? You see x squared plus y squared equal 9. It's a circle. No, it's not circle. It's cylinder. It's cylinder. Because we are working in 3D. In 3D, when the one variable is missing, es cylinder. En 2D es circle, yeah. Pero the problem now is 3D. So we are working example 4, 5, and 6 3D curve in the space. The first equation represents cylinder. Circular cylinder, by the way. A circle, but a cylinder, because it's along the z-axis. Yes or no? Do you understand this or no? Something like that. After, I promise you see in GeoGebra. And what about the second? What is the second? Surface. No. No. No surface. Well, yes, a surface, but one specific. I need more specific. I need the first name and the last name. What kind? X minus y plus c equal 4. What is that? No idea. No idea. Carajo. It's a plane. How do you know it's a plane? Because the exponent f1 is linear. It's a flat. See, we have a square here, a square. Entonces maybe a hyperboloid one sheet, something. Guys, you need to remember this, okay? Okay? This is a moment to open your mind and try to understand 3D. Okay. I know that some people say, no, I never understand 3D. Okay. Go ahead. Stay away from me. This is multivariable calculus. Okay. Entonces now, the curve que we are studying is the intersection surface 1 and surface 2. Surface 1 intersection surface 2 represent a curve. Okay, entonces no, let's do it similar parametrization. I suppose I take advantage que es square plus, entonces es x equal 3 cosine t, y is 3 sine t. It's one possibility, not the unique possibility. And c, well, it's easy. You, in this equation, you solve for c, is 4 minus x, pero es que x es 3 cosine. 3 cosine t, and y is 3 sine. And this is, I suppose, it's a closed figure, because the intersection between cylinder and plane, I suppose, is ellipse, no? Makes sense, right? Cylinder, using the common sense. And plane, bam. The intersection this surface give me ellipse. I don't know. I have no idea. To see clear, I can put in GeoGebra, que es a fantastic way to visualize this. Okay, now the vector value function is r. You put the function que corresponde with the t. I forgot to say que t varies from 0 to pi, no? 3 cosine t, comma, 3 sine t, comma, 4 minus 3 cosine t plus 3 sine t. This is the final answer. However, I want to put a little bit sophisticated using the idea that we told before, que is r of t is, for example, r null. Who is r null? Well, r null plus rho 1 I prime cosine t plus rho 2 j prime sine t. And in our specific example, r null is 0,0,4. Where come from that? Well, we have no plus nothing here, and the only coefficient que do not depend of cosine and sine 4. Plus. Entonces now, you factorization like that, 3, 0, minus 3 cosine t, because cosine we have here in the first component, look, here in the last component, here negative, like a vector. This is totally cosmetic part to see. Plus, plus 0,3,3 sine t. And leave it like that, you can leave it like that. However, in my opinion, more elegant is, bueno, 0,0,4. And do factorization, because I suppose in this format, this and this are univector. Entonces, plus 3 radical 2. I found the magnitude of this vector, no? And the unit vector is 1 over radical 2, comma 0, comma negative 1 over radical 2, cosine t. So the only thing I did was compute the magnitude of the vector 3, 0, comma negative 3. I factor out the magnitude. And here is the unit vector. And this unit vector, in my mind, I consider like a I prime, this guy. Cosine t. Likewise, when you find the magnitude for the second case, in this case, it's the same. And make sense because we are talking about circle in 3D, but it's a circle. It's 0, 1 over radical 2, 1 over radical 2. Sine t. Guys, don't frustrate for this. You don't understand very well, no problem. Because if you leave it like that, it's perfect. That is a super element. This is sophisticated because, you know, I am a picky guy. Do you understand this or no? This part is straightforward. It's a parametric. It's a vectorial. And the vectorial also call you specification the interval also. Let's see a couple more of the example. Do you understand? Yes or no? And what do you define the parametric equation to show what? The parametric equation, well, using your imagination, I explain in 2 dimensions that when you see something like that, x squared plus y squared equals 9, I define x like a 3 cosine and y is 3 sine, no? So I explained before in 2D this idea. The only new thing that you see now is we have C. But it's easy because you take the second surface, isolate the C, put like a function x and y, and you replace x 3 cosine t, y 3 sine t. End the story. Clear or confusing? Clear or confusing? This answer satisfy your question or no? Yes or no? Come on, guys, communication. I am your teacher, no? Crystal clear. Okay. I like Ricardo. Ricardo is crystal clear. Okay. Come back to the whiteboard. Did you see whiteboard or no? Why screw up? Did you see whiteboard? Okay, yes. Another example, 3D. Okay, imagination and common sense. Suppose this x squared plus y squared equals c. And c is equal to x plus 3. We have two surfaces, surface 1, surface 2. And the intersection, surface 1, intersection, surface 2 is our curve. We can represent like that. You can represent a curve like in the intersection to surface. This is not new for you because you remember when you study plane and line, two planes intersecting is a line, no? Entonces, two non-linear, que es a surface, the intersection maybe is a curve. And the curve is the mathematical object, contain only one dimension, but living in the 3-dimension context. This is clear. Therefore, when you define a curve in 3D, you define only one parameter. What is the reason it's only one? It's the reason because it's 1-dimension object. Like a line is 1 dimension. No. The line extending in only one direction. The line have no, and the curve have no width. Okay, have no height. Only is one direction. This is clear or no? Entonces now I need help to identification the surface 1 and to identification the surface 2. Come on, this is part of the game. Come on, I want to hear opinion. Surface 1, surface 2. Come on. Guys, it's super important. I don't like this forest that you put in the background. I say you, the next time I see this forest, I interpret it like disrespectful. I need to investigate who changed that. Okay? Entonces now, forget about this. I said one more time. This is the last time. It's important in the next chapter that you are super familiar with the equation and you recognize when you see one woman, you say one of these women is pretty or is ugly, or this woman is blonde or is brunette. Okay, so to see the characteristic of the equation, you recognize immediately what kind of surface you are working. Okay, what about the first one? What about the first one? I forgot. The first one is x squared plus y squared equals z. Elíptica paraboloide. Very well, Giraldo. Elíptica paraboloide. Along what axis? Along what axis? Along what axis? X along z. Very well. Very well. Okay, repetition one more time. This guy look like similar to this. How do you know? No variable is missing, x, y, and z, but c is linear. And the other is quadratic, is paraboloid, elíptica, paraboloid. Well, in this case, circular, because the coefficient is the same, 1, 1. Super. And what about the second? No, Giraldo, another participation, please. Annette. Guy, I am a little bit happy because you awake and start working in the lab online. A plane. Restrepo, good for you. You are doing well. I check in the work, guys. There are people that don't start, 0%. But there are a lot of people now that start. Guys, you need to do that. Remember, I explained the first day. We have 2 tests for each chat, and we have 4 chats. 2. On paper, written, and online, in the Mama Lab. And you need to finish. And you put a grade in the blackboard, no? When I finish the grade. Okay. One particular situation that you have, pero particular, bam. And the particular you talk to me in private by email, not here. Here, the only conversation I want here with you is mathematics. Any personal situation, and sick, so I don't know, I don't care. You talk to me, I explain me, and to say I standing a little bit, but no. Okay. O sea, it's a plane. Restrepo say que es a plane. Are you agree or disagree with the Restrepo? Restrepo, you are right. It's a plane. This is a plane. I don't know exactly what is the plane, and I suppose the intersection this paraboloid and the plane, I don't know exactly if it's a circle, it's a lake, but it look like, I suppose it's a closed figure. It's a closed figure. Okay. How do you find that? Well, you put both equations together. Suppose I put x squared plus y squared is equal to x plus 3. Now you manipulate this like a classical manipulation. You complete a square or something. Bam. Let me try. This is x squared minus 2x plus box. Plus y squared. We have no linear y. Okay. And you know, 3 stay here. Why not? Plus another box. And the magic number that completes the square is obvious que 1, no? So the factorization, the trinomial is x minus 1 squared plus y squared equals 4. Nice. This is the, entonces this is a circle. This is a circle, right? Wait, I forgot something, no? No. It's a circle, yeah. It's a circle. Well, okay, so you want to express the circle in standard, you divide by 4, everything. Entonces x minus 1 over 2 square plus y over 2 squared equal 1. And you define this like a cosine, and you define this like a sine. Entonces es, en my parametric equation is x, bueno, x minus 1 over 2 cosine. Therefore, x is equal to cosine t plus 1. Likewise, y over 2 is equal to sine t. Therefore, y is equal to sine t. And what about z? Because we are working in 3 dimensions, we need 3 parametric equations, no? I want to see it's easy. You go to the easier equation, okay, in my opinion, is this equation, the plane equation. Actually, the C is already isolated. Good, very good. Therefore, C is equal to 2 times x, but who is x? X is this, 2 cosine t plus 1, 2 cosine t plus 1, plus 3, no? Now C is equal 4 cosine t plus 2 plus 3, no? Que 5. Entonces C is equal 4 cosine t plus 5. Let me summarize. The parametric equation for the hour curve is x equal x equal to cosine t, 2 cosine t plus 1. Y is equal to sine t. And C is equal 4 cosine t plus 5. And t variable is obvious from 0 to 5 because it's a closed curve. This is the correlation for the parametric, and so you express it like a vector. You express it like a vector. Is r to any time is equal. Is equal. I want to express directly like that. 1, 0,5. This is r null. Guys, either way. Okay, suppose you don't like this way. Okay, no problem. This is cosmetic. You express it like that. You copy vector and you copy x. X was 2 cosine t plus 1, comma. Y is 2 sine t, comma. And C is 4 cosine t plus 5. End story. You can separate like R null, you can, but no, it's okay. It's okay. It's okay. Let me try to make easy. Any question? I promise you see in GeoGebra now in 3D. One more example and that's it. End the story. One more, the last one, I promise. Because I have a lot of things to discuss in today. Example 6, no? I want to feedback. Everyone follow me or you are totally lost? Answer me. Ane, answer me. Carlos, answer me. David, follow it. Clear. I suppose I am working with the advanced students. Okay, all good, very well. Okay, example 6. It's easy also. It's x squared plus y squared equal 4. And C is equal xy. This is surface 1, que es obvio que es cylinder, right? And surface 2, I have no idea. It's crazy. Because we don't study this. Never. And the collection of the most important surface, we have infinity surface, you see, no? Hello. However, you study the most important, no? Paraboloid, ellipsoid, hyperboloid, 1 2 sheet, cone, etc. But this I have no idea. But it's not important. It's not important for us now. Pero bueno, okay, what is the goal? The goal again is parametrization and representation like a vector value function. So one more time, we're using the idea that this is cylinder is and 2D is circle. Entonces x over 2 square divided by 4, no? Plus y over 2 square equal 1. Entonces I know que x is equal to cosine t, y is equal to sine t, good. And C is the multiplication this and this, que es 4 cosine t, porque 2 times 2 is 4, no? Cosine t, sine t. You can leave it like that, or more elegant, you know, sophisticated, is using the formula of the double angle. Que you know que sine 2t is equal to sine t cosine t, no? It's the famous formula that we use in calculus to any time. This is 2 times sine 2t. Therefore, the vector value function associated with this curve is the component is 2 cosine t, the component y is 2 sine t, and the component z is 2 sine 2t. And you see now, okay, in this case, you have different omega. Omega is 1, but omega is 2. And you take the smaller, so the interval is from 0 to pi. It's a closed curve, but you see now, I have no idea, but you see in GeoGebra. GeoGebra helped me to visualize what is the influence, what is the new thing that bring me this double angle in the curve. Okay, guys, let me try. This was easy, at least the algebra part. Let me try to find the folder in GeoGebra of the 3D. Open. Okay, curve, the part 1, yes, this one. Wow, what the hell? Good. Okay. Okay, let me share the screen. Share screen. Switching to this. Boom, and boom. 3 boom. Double boom. Do you see your algebra? Yes or no? Do you see or no? Do you see or no? Answer me. Yes. Restrepo always help me. Okay. Okay. Entonces, I go back. Not yet for me. Gerardo. You know, sometimes happen. I notice that we have one delay when it's switching something. It's normal. I see now. Okay, super. And Gerardo, you see now? Yes or no? Come on. Not yet. Wow. Well, hopefully soon. Okay. Okay, guys. Okay. Let's come back. Go back to the example 4. Example 4, you remember the surface are cylinder. Bang. You see cylinder? And the plane. Bang. And the intersection with the cylinder and the plane look like this ellipse. Let me remove the plane and the cylinder to see only the curve. Que es the thing we studied today. The thing we are studying today is not surface, it's curve in 3D. And the parametric, look, the representation is this. Okay, remember, and the GeoGebra give me parametry, but give me different to my parametry, but it's normal because the parametry is not unique. Okay, I understand that. But this is clear. Look, intersection between cylinder, circular cylinder, and the plane was the curve. Super clear? In example 5, we have a paraboloid, look, elliptical. Actually, it's not elliptical, it's circular. Look, it's a circular. Because the coefficient is 1, 1. And the plane, boom. This is the plane, wow. And the intersection between the paraboloid and plane was a curve. Of course, closed curve again. It is another ellipse in 3D. And we discover the parametrization this. Okay, super. Nice. Do you understand this or no? Everyone follow me? Do you understand? Okay. A curve, I repeat one more time. It's one dimension object. Because we have no area, we have no height, we have only length. In this case, it's a circular, closed curve. It's one dimension, but this one dimension object living in the three-dimension context o environment. Entonces, the reason que the parametric represent a one parameter que es t, because one dimension object. Suppose, again, the famous cylinder, and the last example, and the other surface is, wow, what the hell is that? Well, this is the hyperbolic parabolic something. Okay, and the curve is look like that. Boom, boom. Look at the curve. The curve is no ellipse. That is the influence, the double angle. It's no influence. Okay, so at least this is the introduction to the parametrization, o sea, vector value functions in 2D and 3D. Okay. 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 Everything okay? Let me switch into the algebra, to the whiteboard now. Whiteboard now. Okay. Okay, whiteboard now. Okay, guys. Okay. All good. Okay. Look crazy. Yeah. This is hyperbolic. There are infinity possibility of the surface, no? You know. It's exactly we are infinity of curve in mathematics, no? Okay. Let me try to explain something new, completely. Please, concentration, get focuses. Entonces now I want to explain R length reparametrization. What the hell is that? R length reparametrization. Well, the word reparametrization means, I suppose, que you change the parameter, not t anymore. No. So you know the formula for the R length we studied last class. R length is integral from A to B of the speed, and the speed is the magnitude of the velocity, and the velocity is the first derivative of the position. No? This is clear for you. Okay. Now I want to propose you change the parameter t to another parameter that I want to call s. And what is s? It's the R length. Entonces es no L anymore, it's S, because I want to travel onto the curve. I put this like a T. Entonces actually this S is no S, es S of T. Es magnitude, sorry. Let me change the variable U. Entonces, what is the idea? This is the cumulative R length. So we travel now, suppose we have the curve like that. This is the point A, and you travel here on the curve. And this is not B, this is T because it's a variable. It's a function, it's a cumulative distance, R length. Entonces, es obvio que this new function ST is monotonic increasing. Because I assume that the first point is A, and when you travel onto the curve, the function is increasing because it's more distant. ¿No? Es obvio que es differentiable. O sea, es smooth curve, es a smooth function. So I suppose that we have no gap, we have no corner, we are point like that, no cup, corner. Okay, it's smooth. I suppose, no. I suppose that, for example, at t equal a, que es the original point, the function a is 0 because the limit is the same, no? A. So basically, the meaning of this is we don't travel, we stay in the point A. However, when you put for the point B, it's L. It's L. Okay? It's L. And L is the distance. So basically, it's the same formula for the length, no? Okay? Now, entonces, what is the idea? The idea is change the parameter D for the parameter S. And what is the advantage? Well, okay, it's hard to understand. This is complicated, very complicated this for different reasons. The parameterization using R length give me the possibility that my equation look like easy. The equation que we study after that. Okay, que es called Fresnel-Serret formulas. The formula que help me to understand a little bit much better the geometry of the curve. The formula using parameter T is easy. But what is a big problem? Que sometimes happens que it's impossible. For two reasons. Reason number one, well, the parameter S you find using the integral. And you know that not every function have the antiderivative. Sometimes it's impossible to find the antiderivative. And the complexity of the algebra and state relationship between T and S, sometimes it's impossible. Entonces now, in my opinion, the value, the utilization for the R-length reparametrization is theoretical. Pero I need to study that to present the equation, to say, you see, well, professor, I don't understand where I come from, this equation. Okay, let me try to present to you one elementary example, quickly, of the reparametrization. Suppose that we have a curve. Okay, this curve is cosine t, sine t, comma t. Wow, what the hell is that? Guy, using your imagination, what do you suppose is that? It's a curve. Okay, the first component vary according to the cosine, the second component vary according to the sine, and the last component very linear. Using your imagination, try to imagine this curve. How look like this curve? Idea. Come on, Anne, Carlos, Restrepo, Jocelyn, Brandon, Thomas, Omar, Borja, Phoebe, Daniela, Claudia, Ricardo, Marco, Gerardo, Highlandford, and Robin. No idea? No idea? Okay. It's weird, right? No, it's not weird. But okay, forget about that. Suppose I want to find the parameterization, the reparameterization. Okay. You see clear now after. I compute the first derivative. Get the velocity. The first derivative is derivative cosine is sine minus sine, no? Comma. Derivative sine cosine. And derivative t, we will repeat the t, of course. When this prime is dt, dr dt. This is equivalent to say dr dt. Well. Now you find the magnitude. Okay, remember the magnitude is speed. This is equivalent to a speed. How fast? But not Victoria, scalar. And that is square root negative sine t squared plus cosine t squared plus 1 squared. But I know que sine squared plus cosine squared is 1. This guy is 1. And 1 plus 1 is 2. Entonces, unbelievable, but the speed is constant. Es radical 2. Okay, entonces I go to the formula for the community R length, que es the parámetro S. The parámetro S is the integral from 0, I assume 0, A0, to t, to the speed, que es radical 2 dt. Wow, super easy in this case. It's of course easy. Another function is very, very complicated. Entonces, radical 2t. The mathematical relationship between S and T is que T is equal S over radical 2. And you replace in the original equation, you want to express it, no using the parameter T, sino using the parameter S, is cosine S over radical 2, comma, sine S over radical 2, comma, S over radical 2. And the story, this is the reparametrization using R length. Entonces, no, okay, the thing can fly in the air. Bueno, professor, what is the application of this? Well, in the equation that we studied before, I expressed the equation, use the parameter T, and use the parameter S. And you see sometimes the equation using parameter S is easier than the parameter T. But I recommend always using the parameter. But I need to present the equation, no? So you see one advantage of this reparametrization is, bueno, suppose I want, okay, let me try to, okay, listen to me. Can nobody answer that question? What is the representation that occur? What is the representation that occur? Well, that occur is a circle, no? This and this is a circle. But this is T is a C component increase. Entonces, this is look like that. Look at that. Okay, like a spring, no? This is helix. Make sense or no? Make sense or no? It's a circle, but the C increasing linear. Entonces, a circle in different height. Okay, this is the helix. Okay, Entonces, when you reparametrization, I want to find the position of the one point when for example, I travel S equal 10 meter. So you travel for this red part is 10 meter. Boom, and stop here. So the distance travel on the curve que I represent using the red color is 10. Entonces you find the position here, x, y, z. Where? How? Well, plugging in here in the equation. S10, S10, S10. Ese is one advantage. I want to prove another advantage, that the speed is 1. So when you travel for the R length, the speed is 1. No 100, no, it's 1. So you go smooth, you could slow down onto the curve. And several, advantage. Okay, guys. I know that you have a lot of questions. It's normal because it look like weird, very, very weird. Okay, let's move on to the most important part today. Only the most important is the last part. Okay, we study now the TNB frame and frenet serret formulas. So actually, this is two things. I want to explain first TNB frame, and after I want to explain the formulas. Okay, frenet serret formulas. Okay. This is 3 vector. Okay, T is called tangent vector. Unit tangent vector. Let me copy properly. T, capital T, is unit tangent vector. M is unit also normal vector. And B is unit binomial, binormal vector. And this is similar to the famous IJK that you know before. Okay, remember this is orthonormal base. This is also orthonormal base, but the only difference is that this vector que es orthonormal is static. It's not moving. And this guy is moving along the curve. So we have a curve, suppose we have a curve in black color. In one specific point, I have 3 vectors. And this vector change point by point. Well, for example, using this color, not necessarily any book using this color. Tangent vector, tangent normal vector blue. Normal vector is red. And binomial vector is green. In this case, down. Entonces, en the other position, bueno, okay. The normal vector, the tangent vector, sorry, is like that. Now, the tangent vector indicate the like speed, no? Is in the direction. I want to explain now in detail. So the thing I try to explain now is que this frame que es orthonormal base similar to the IJK, but the problem is que IJK is static, never moving. IJK is static and this is moving. Okay, how moving? I want to explain now. This is the idea. Binomial is supposed to that. Okay. What is binomial? I want to explain now. Relax, cool down. This is complicated, guys. To say now, one thing is very complicated. I need to explain step by step. The only thing I try to explain is that we have 3 vectors. And this vector is moving along the curve, no static. Okay, but I want to explain. Okay, so now I need to come back. No, I need to come back to the, sorry, carajo. Okay, no, stop sharing. Do you see my face now? Do you see my face? Do you see my face or no? Do you see my face or no? Yes, okay, good. That is the reason I don't want you change the background. Because I want to explain something. Look. And you don't see very well this something. I don't know how to change the background. I don't know. I mean, it's supposed to here. No, I don't remember how you change the background. Let me see. No. You don't see this, no? Or you see? You see this or no? No. Okay. Please help me to change the original background. I don't know. See, I click here, I close everything. The camera, maybe, no? Let me see. Choose background. Effect. Okay. I choose this. How you confirm that? Camera. I'm present, no? I don't know exactly. I choose this. Camera. Okay. How you close that? No, close. No change the background. Guys, do you understand that this is crazy? Okay. The thing I bring here is an airplane. Do you see the airplane? No. Carajo! Don't change the background anymore. No. Okay. Okay, guys. Okay, suppose the thing I bring, suppose we have airplane. I put in paper, one airplane, like that. And just this airplane travel in this point, or in this point. Entonces, the unit vector is a point, es the vector que point to the nose of the airplane. And this represents velocity. Of course, no velocity, because velocity is, suppose, 200 miles per hour, no? But this is a unit vector, pero indicate direction. Unit vector indicate direction. And the normal vector, okay, give me the information when the airplane turn off to the left or to the right. Turn off to the left or to the right. So suppose that we have one trajectory like that. Like that. Ooh. Okay. Suppose that this is a straight line. We have the airplane here. Professor, I can see the whiteboard. Oh, I understand. It's too hard. Now, everything okay? Okay. Okay. Okay, super. Guys, I prepare my lecture because in one moment you need to see my face. You put one stupid background. Just, this is impossible. Ah, okay, support, sky, meeting. What the hell? Oh, let me see. Okay. Okay, I try to explain. Focus, guys. I bring one airplane in paper that represent this airplane. This airplane travel on the curve. This is my curve. Suppose that this part is totally straight line. And this is my airplane. And my airplane, the unit tangent vector pointing to the nose of the airplane. So the unit tangent vector indicate the direction can you travel. So you change the direction. This is my unit tangent vector in this direction, but in this case, change. This unit tangent vector is parallel to the velocity, but it's unit vector. The magnitude is 1. However, in this case, we have no normal, because you go straight. As you turn it to the left or to the right, like that, you have normal vector. Normal vector give me information in any point when the object can moving on the curve, turning to the right or turning to the left. Do you follow me? Okay. Entonces, I suppose in my mind que unit tangent vector is always one vector que point in the direction for this wing. Normal vector. And binomial is like that. Binormal. This is the most complicated part to understand. Binormal is a vector that give me the information. Suppose that the airplane travel in one trajectory que es totally coplanar, like that, coplanar. We travel in the same plane. It's the same plane. Entonces es obvio que the last part of the airplane don't change the direction. However, si you change the plane, I try to explain using one PowerPoint I sent to you, open it at home and try to see. In other words, normal vector indicate me the direction and what you turn in to the left or to the right. And binomial vector give me the information when you change the plane. For example, in the helix, like that, so you travel in one trajectory like that, it's obvious that you change the plane. Therefore, the binomial vector change. This is a little bit confusing or clear? Repetition. 3 vector, fundamental. Tangent, normal, binomial. Tangent is the nose of the airplane. Normal is the wings of the airplane. And I don't know exactly what is the name in English, or the last part of the airplane is indicated by normal vector. Entonces, you define perfectly in any point of the curve 3 vector. Entonces, these 3 vector give me more information. Look. We have 2 more parameters. So this is a vector TNB. However, we have 2 parameters, important, extremely important parameters. The first one is called curvature. The representation mathematical, the letter that represent curvature is this letter. It's not K, it's a Greek letter, it's kappa. I don't know why. Kappa. Torsion. Torsion is tau. Tau. Torsion. What is that? What is that? What is curvature? Interpretation curvature. Okay, the most important is interpretation after we apply the formula and end the story. Okay, curvature. Curvature is, look, when you analyze the curve and the space, suppose that we have a straight line. It's obvious that curvature is 0 because it's a straight line. No turning to left or to right or up, down, no. A curvature is 0. Now, perfect circular motion. Curvature is equal the reciprocal of the radius of curvature. Okay, it's constant. It's constant. So curvature is constant. Like, what is curvature? Suppose a curve, the totally curve like that. Ooh. At this point, the curvature is a big value. Suppose, I don't know, I can compute it, 20. And this, you know, is almost 0.1, because it looks like a straight line. The curvature again is maximum, it's 30, no? The curvature is a scalar, it's a number. Give me information how much curvy is our curve. In other words, let me try to explain using my imagination. Is give me a measure how our curve follows the straight line. Make sense or no? I promise in the example, I don't know if we have time today or no. We discussing today. Do you understand the idea for the curvature? Suppose ellipse. Suppose ellipse. In this case, the curvature is maximum. In this case, the curvature is minimum. Because this, okay. Entonces, to represent, to have some idea of the curvature, the mathematician using one thing is called osculating circle. Osculating circle is a circle. Here, osculating is a Latin word that is similar to the kiss. So at this point, our curve and the circle make a kiss. At this point, share the point, have the same normal vector, saying the same tangent vector. And in this moment, this osculating circle have a radius, and this radius is rho, que es the reciprocal of the curvature. For example, in this point, the curvature is bigger because this look like a little bit approaching, no, to the straight line, and the osculating circle is something like that. Okay. And suppose that this is the center. Suppose this is a radius of curvature, que es the reciprocal of the curvature. Same formula. This is the curvature. And the torsion is more complicated to understand, but I try to explain. Torsion is similar to the curvature, but it's the measure how our curve follows the plane. So you deviate to the plane, you have torsion. So you stay in the same plane, for example, one trajectory, que es totally planar, the torsion is 0. I promise you see example in 2D and 3D. Okay. So one more thing important. Well, the important is the formulas. But before the formula, I want to present to you one algebra in which you see more clear this idea. Look, okay, guys, the most important is understand the concept. So what parameter, what is the meaning of the parameter that I'm looking for? Curvature. Curvature. Look at that. This is a fantastic script I create for you. I send the screen, guy. Wow, wow, what the hell is that? Look at that, look at that. Okay, I suppose, can you see that or no? You don't? Okay, you don't see. Okay. Wait. Switching. There you go. Okay. Try. Do you see your algebra or no? Okay. Okay, look. This is an elementary example about the elixir. So elixir is, okay, this, let me delete that part. Elixir is the red curve. Okay, parametrization, I know that part, but I compute the tangent vector. In this case, go to the opposite direction because in GeoGebra go in both directions. However, the most important I want to show you is the osculated circle and the curvature. Okay, okay, the curvature. Let me activate the oscillated circle. And the right hand side of the window, you see the curve que corresponde with the curvature. O sea, you can see that now when you go to this point, the curvature is maximum and the osculated circle is smaller. When you go to this point, the radio of curvature is maximum, the curvature is minimum. Do you see or no? Do you see or no? Okay, the thing I try to explain is, what is the idea for the curvature? Totally new that you never see before in your life. And osculated circle. Do you understand this or no? Question. This is a moment to ask me a question. Professor, what the hell is that? Calculus 3. Any question? Do you understand this or no? Gerardo? Thailand? Roy? Marco? Ricardo? Claudia? Guy? What's going on? Okay, I understand. Okay. I know that you don't understand 100%. So next time, next time, I promise you understand 150% because we are doing word problem, no? Okay, but before to conclude everything, I sent to you in this email, I send the link. I sent to you today, no more. Okay, listen to me. I try to explain. Let me focus. I want to stop sharing. No more sharing. Do you see my face? And inside the forest, no? Guy, I don't want this forest anymore. Okay? I send in this email. I send one PowerPoint, one paper of the formulas that we are using next time. I don't see the formula, invisible formula. The formulas and the review. So 2 pages and PDF for the review. My plan at the beginning was Monday and Wednesday next week doing the review. I don't know. I need to dedicate some time for the problem of the curvature in 2D and 3D and tangent unit vector, normal vector, binomial vector. You have one roughly idea physically. What is that? Well, so then Monday I start doing the problem and I start the review. The review is easy problem, no big deal. So every student, normal student, is present here in every lecture can do that. Okay, don't expect que the test is super hard. No, ese es easy. Ese es normal. Okay, ese es normal, ¿no? Es typical. Maybe sometimes some question is confusing, pero no, pero when you, I try to solving, I dedicate to lecture solving this. And after when I finish that, we are ready to take the test number one. I saying, yeah, you take at home, of course. You have to everyone know me. You can interchange with you, and send me back the answer, okay, by email. Entonces, maybe the day I planning is no good because in the real time, in the real life, I need to continue one more day, but not too much, only one more day. How many questions is 10, no? 10. In the review or in the test? In the test is 10. I say at the beginning in the syllabus. Do you remember? 10 questions in the test reading on paper. And 20 online. The due date I planning was May 28, no? Pero well, entonces, if you need, because I can extend it, I control this, no problem. I can control the due date. Okay? The most important is, guys, I want to see that you are struggling doing the homework, doing the pre-test. Si you are lazy, this is not your place. I put 0, 0,0 in 3 dimensions. 0,0,0. This is your position. Okay? Okay. Reading test. What is the question, Gerardo? Reading test. What happened with the reading test? Now let me see. Reading test. Reading test is online. Yeah. Okay. I'm waiting the same. I'm waiting the same. The same weight. Do you like Leonardo 0,0,0? Leonardo, you are a good student. There are a lot of good students. I saw your performance so far. I am proud. Pero everyone need to improve. Any situation, any particular situation, communication. This is online. And online, no communication, we are totally lost. Okay, guys. We see next Monday.